Up to this point, with all of our prototypes, when you clicked run, you would just get thrown right into the gameplay. No hello, no how are you, just right to business. Then during runtime, we've never tracked score, lives, or progress, so there was no real way for the player to tell how they were doing. And finally, when the game was over, the only way to restart the game was to stop the project and rerun it. Well, in this unit, things are going to be different, because we are going to create a prototype that opens with a beautiful title screen, where the player can choose the difficulty. Then during the game, the player's score will be tracked and displayed, and at the end, there will be a game over screen, where the player will be able to restart without rebooting the entire application. That right there is a 5-star user experience. All of those elements you just saw, the title screen, menu buttons, score display, and game over screen, fall into the all-important mission-critical category of user interface, or UI for short. The UI includes any text, buttons, or display that the user can read or interact with during their experience, and that is going to be the focus of this unit. As you saw, having a UI in your project makes it look a lot more professional, but it also allows your project to be fully playable. A fully playable game is one that the user can experience seamlessly from end to end without any game-breaking bugs or missing features. Having a UI will finally allow for that. It is the missing piece that will tie together everything you've learned up to this point. So without further ado, let's start creating. In this prototype, objects will be tossed into the air, and the user has to click on them to destroy them. So the first thing you'll do is decide what kind of objects you want to obliterate. You could choose between sports balls, you could choose fruits and veggies, you could even choose the ingredients for my favorite healthy breakfast, pizza, cookies, and energy drinks. Whatever you choose, by the end of this lesson, the objects you want will be launched into the air, and when you click on them, they'll be destroyed. To make this game as fun and fast-paced as possible, we're going to give these objects not 1, not 2, but 3 randomized variables. The position along the bottom of the screen will be randomized so the objects can appear from anywhere. The upward force will be randomized so that the objects fly up to random heights. And the spin or torque we apply will also be randomized so that some objects spin this way, some spin that way, and some barely spin at all. As you can imagine, our old friend random.range is going to be heavily involved in all of this. To destroy the objects, we'll also be testing for a brand new type of user input, the mouse. Unity can easily detect where and when a mouse has been clicked in your game. You can tell when the mouse enters an area, you can tell when the mouse button has been pressed down, you can even tell when the mouse button has been released. All you have to do is detect if a user has clicked one of our objects, and if they have, we'll destroy it. So to make all that happen, I'll see you in Unity. All right, so working on this. In fact, open up prototype down to the instructions below the video to download the starter files yourself afterwards. Now I'm going to go through and import these assets and open up the Unity project, so I'll see you in a little bit. In your Assets folder in the project window, select your Scenes folder, open up Prototype 5, delete your sample scene. Now let's reposition to our camera. So now you can see our background for Prototype 5. In fact, our camera is currently set to this 2D view, so we can actually just set our scene view to 2D. This will in fact actually make it easier for us to interact with this scene, because while we do have 3D objects we're using, we're generally just going to be working on this 2D plane here. We could have done that for some of our other projects, but it's always good to get comfortable moving things around in the 3D space. In fact, if we select our Move tool now and select our background, for example, we actually only have arrows for the Y and the X axis. There's no Z axis because we can't go forwards or backwards. We can only go up, down, left, or right. And then one more thing that we can do, if you want to, go to your course library in your Assets folder. In the Textures folder, expand that. And there's actually all of these different textures that we can use. So, for example, background. Now, the first thing that we'll need for this little game is 3 objects that we're going to collect and then a bad object to avoid. So we're going to go into our project window. We're going to, under our Assets folder, expand our course library. And then in our course library, we're going to expand our props. Now you can see we have a bunch of different options here, from bad things we don't want to collide with. We have different balls we can use. We have food. There's other types of things. So I think I'm just going to use some of these other objects here. So I like the look of all of these different crates, so I'm going to go and drag them into my hierarchy. And you can kind of see they're stacking on top of each other, so we'll just go and we'll use our Move tool. And we'll just drag them onto our scene so we can see them. And then we need a bad prop to use, so we'll go into props, bad, and we'll just click and drag. I'll use a skull as one of my bad props that way. It's very clear which ones are good, all of these different crates over here. And then we have our skull, which we definitely don't want to press. Now we're going to rename all of our props, so that way it's easier to manage them. So we'll name the skull, and we'll just make this very simple. So we'll call this bad one for the first bad prop. In our crate, we'll name this good 1. So this is the first one. We have good 2. And then our last cube will be good 3. Now, on all of our props, we actually need rigid bodies and box colliders. Because this game is going to be a bunch of objects being thrown up in the air and then falling, we need the physics for that. And then we need colliders because we're actually going to add triggers to each of these boxes as well. So I'm going to select the first box, and then I'll select the last item on the list. And I'm just going to add components. So I'll add a box collider, so hopefully it works on all of them properly. And then I'll add a rigid body. So now we have box colliders and rigid bodies applied to all of them. Now what we're going to do is in our Assets folder, we're going to right-click on it and create a new folder. And this will be for our scripts. And then in our scripts folder, we're just going to make a script called target. And then we're going to select all of our different objects as well, and they'll all use the same target script in general, so we don't need to get very fancy with this. So now you can see they all have the target script applied. Now in our Assets folder, we'll create a new folder for our prefabs. Now we're going to take each of our different objects and we'll drag them into our prefabs folder. Make sure you create original prefabs.
And now, since we have all of our prefabs, I'll just go and delete all of these objects in our scene now, because I don't think we'll need to edit them much later, so delete, and now we're good to go. So what you're going to do is you're going to go into your course library folder underneath props. You can pick a bed prop that you're going to use for your game, and then choose 3 other props. They can be balls, they can be food, they can be any other kind of prop that you want to use. Make sure on all of the props you add a rigid body and a collider. In our project window, create a new folder for your scripts and create a target script that you'll then apply to each of your different objects on your scene. Once you have the box collider, the rigid body, and your script applied, create a prefabs folder. Drag and drop all of your different objects into your prefabs folder, create original prefabs, and then you can see all of the different prefabs here with all of the components applied. So now it's your turn. So we have each of our different prefabs created, and we've applied our components to them. So now we're actually going to use our target script to control the force that they move in the air, the random position that they start off at the bottom of the scene, and then torque to be able to rotate the object. If you double click on your target script, now with our target script open, we're going to create some variables. So we're going to create a private variable for our rigid body so that we can just find it using getComponent. And we'll call this target RB, since each one of our different objects are the different targets we're trying to hit. In our start method, we're going to take target RB and we'll set it to be the component on our object, which is our rigid body. Now that we have our rigid body component, we need to apply a force on our object so that when it spawns, it moves up in our scene, so then it can fall down. So using our target rigid body, we're going to add a force. In this case, our force is going to be in the up direction. And we'll multiply this by a random value for now, so we're actually going to use our random range method. And we'll set it, just to test, we'll use 12 as the lowest value that it can be and 16 as the highest. And we actually want this force applied instantly, so we'll use a force mode. And we'll use our impulse. Another thing that we want to do is we actually want this object to rotate and move as it gets sent through our scene. So we're going to use our rigid body again. This time, we're actually going to use torque. So add torque. And so torque will actually apply the force for our objects to rotate. In this case, we just need the directions that the torque will be applied in. So we'll use random ranges for our X, our Y, and our Z. So we'll randomly generate a value that it will rotate in, say, -10 and 10. So that's on the X. We need to generate another random value. I'm just going to actually reuse this bit of code. So I'm actually just going to copy this. And I'll paste it into our Y value. And then I'll paste it into our Z value. So our X, our Y, and our Z are all calculating different random values between -10 and 10. Again, we want this force applied instantly, so we'll actually use another force mode. And then we want to set the position of our object randomly on our X. Finally, what we're going to do is we're going to create a random place for our different object to spawn. So we're going to get the position of our current object, and we'll set this to be a new vector3, and for the X it'll be a random range. So we'll try and keep it between, let's say, like -4 and 4. So this way it stays between the left and right side of our screen. For our Y value, we'll set it to something like -6. That way it spawns underneath the scene. And then for our Z value, we can set it to 0. Now if we want to test and see how this looks, we can actually drag our prefabs into our hierarchy and we'll randomly create those effects. So it has the random position, it's got the random force applied. Now, one little bit of clarity that we can actually add. So since we're not actually using the Z value here, we can actually remove this. And since we're not really moving anything on the Z in general, in this case, it'll set the X to be a random range, the Y will be -6 underneath what our player can see, and our Z is always just going to be 0. So what you're going to do is in your target script, you're going to create a rigid body variable. You're going to get the reference for that rigid body component. Now that you have your rigid body component, add a force in the up direction using a random strength between 12 and 16. And make sure that you apply the force with an impulse. In our next line of code, we're going to add torque to apply rotation to our object. And we're just going to use randomly generated values for all of the different X, Y, and Z. And then we're going to set the position of our object to be a random range on our X and just below what our player can see on the Y. Now it's your turn. So we have our script for our target set up. We're just going to do a little bit of cleanup just because we have a lot of these different methods and we have a lot of different hard values. So we're going to make our code just a bit more readable. So we have values for our speed. We have values for our torque that we're going to apply. We have a range for X position and we have our spawn position. So we'll just create a bunch of those variables. So we'll make a private float for our min speed, our minimum speed. And we'll set this to 12 for now. We'll make another float for our max. And this will be 16. For our torque, we'll make a new vector3 method, so that way we can return a vector3, and this will be for our randomness method. We can do the same thing for the torque. Since random just returns a float, we'll use our float, call this random torque, random ranges, and we'll just paste our random torque method into each of those different parameters. Random variable with multiplying a vector3 that already exists and multiplying it by. Now, one thing you might notice between our random spawn position method that returns a vector3 and random force that returns a vector3 is that our random force does not use the new keyword versus our random spawn position, which does. That's because with random force, because we're multiplying a vector3 that already exists and multiplying it by values, we can return that vector3 immediately. In our random spawn position, because we're actually creating in our different helper methods, we're doing different things. We have all of our prefabs set up so they're randomly spawned at different positions. They have different forces applied to them so that they fly up the screen. Now we're going to use a list to keep track of all of these objects to spawn them. But instead of using a spawn manager, we're actually going to create a game manager, since we're also going to use the game manager to control the states of our game later. In your project hierarchy, if you click the create button and create an empty for creating an empty game object, we'll rename this game object as game manager. And then we need a game manager script to be able to actually use it. So in our scripts folder, if we right click, create a C# script and call it game manager, we'll now apply our game manager script to our game manager object, and you can see that it's applied. If we open up the game manager script, now we're going to do something similar in our game manager script to get the list of all of the objects we're going to use. So we're going to use public so we can apply the references. But instead of using an array, we can use a very similar data structure called a list. And then with a list, we actually need to give it the type of something. So we'll create a game object, and we'll call this targets.
When you first add a list variable, your code editor will likely show a red squiggly error line. Looking at Unity's console, you'll see an error message that says the type or namespace name list could not be found. Are you missing a using directive or an assembly reference? That may sound familiar to you. Similar to what we saw with coroutines earlier, we just need to include another using directive. Most code editors will show you a quick fix option when you hover over the error. In this case, it will suggest that you add using system.collections.generic. Just add that line at the top of your code along with your other using statements, and this will let you work with the list type. After adding it, you should see the error disappear in your IDE, and when you save, the Unity console error will clear up as well. Now that we've taken care of that, let's continue exploring how to use this list.
Now, a list is extremely similar to an array. So if we were to create our own array, we could call it game objects and then targets2. And you can see I misspelled game objects. So the notation is very similar, but with a list itself, we can actually pass it in the type of thing that we want, versus with an array, we have to tell the array what that thing is before we make the array itself. Overall, lists and arrays have slightly different functionality. So there are times where a list is more useful than an array. But for the purpose of this project, we'll just use a list for now so that we can kind of get used to it and see how it works and how similar it is. Now when we save, When we go into Unity, you can see our game manager script. It has the name of the targets. We can create a size, very similar to how we made a size for our array. So we'll set this to 4. Now we have 4 elements that we can give it. So we'll give it the bad object, the good object, the second one, and the third one. So what you're going to do is in your project hierarchy, you're going to create a new empty object, call it Game Manager. You're going to create a new script called Game Manager, apply that script to the Game Manager object. In your Game Manager script, create a new public list of game objects. And then in your Game Manager, just make sure that you apply the prefabs onto each of the different elements. Now it's your turn. We've created a Game Manager object that has our Game Manager script that now can control all of the different prefabs that we have. Now what we'll need to do is we want to instantiate them over time, so we'll use a coroutine again, and we'll learn about a new loop that we can use to do that. In our Game Manager script, we're actually going to create a new method first. Now we're going to create another IEnumerator method called spawnTarget. That way we can actually use the waitForSeconds method to control the length of time between each spawn. We need to use the yield keyword again. And we need to return a new waitForSeconds. And it needs a float of seconds. For now, we'll just use spawn rate because we'll create the variable later. Now we need to actually get a random object from our list to use, so we'll use our index so we can select that object in the list using its position. we'll get a random number between the first object and the last object. So similar to how in arrays we got the length, we can use targets, but in this case we actually get the count. And so this will actually give us the count of how many objects are in that list. In this case it's 4, so it'll be a random number between 0 and 4. And then we need to actually instantiate that object. So using our targets, we select the one at the index that we're going to use, so that way we either get our bad object or one of our 3 good objects. Now, the loop that we're going to use to control this is called a while loop. And a while loop is a fusion between a for loop and an if statement. So an if statement requires a condition to tell it when to stop. A for loop will iterate over something a certain number of times to execute your code. So a while loop will execute your code continuously, but instead of giving it a defined number of times to run, we can actually use a condition to tell it when it should actually stop running. We don't actually have a condition we're going to use just yet, so we'll just set this to be true. So while this is true, which will always be, we can do our line of code here to spawn our objects. Our spawn rate is still mad at us because it hasn't been initialized yet, so we'll create a private float spawn rate, and we'll set that to 1 for now, so it'll spawn every 1 second. Now, in our start method, we'll use a coroutine to actually start that spawn timer. So if we start coroutine, spawn target.
And then there should be one last error coming up under IE numerator. And this should be somewhat familiar to you now, because if you hover over the error and look at the quick fixes, once again, it looks like we're missing a using directive. If you select that quick fix option, it will add using system.collections to the top of our code with the other namespaces, giving us access to the IE numerator functionality, getting rid of that error, and allowing us to proceed.
Now, after we've saved, if we go to play our game, you should see through the magic of our programming that we have all of these different obstacles, and even though they're running into each other, that's totally fine. You can see it's randomly creating different obstacles over time. What you're going to do in your game manager class, make sure you create a spawn rate to keep track of the number of seconds that you want something to spawn. You're going to create another IEnumerator method for our spawn target. We're going to use a while loop, and for now our condition will just be that it's always true. In our while loop, we will yield return the wait for seconds using the spawn rate that we actually wanted to spawn at, so 1 every second. You're going to get the index of an object to choose from our list, and then you're actually going to instantiate that object using the index to grab it from our targets list. And then in our start method, just create a coroutine using start coroutine, and then call our spawn target method. Now it's your turn. Now our objects are all spawning using our game manager, and every second you'll see a different object being created. Now you can see over in our hierarchy that we have all of these different objects that are continually being produced and not being destroyed. So we'll need to destroy them in 2 different ways. So we'll actually get a register for when we actually click on one of these different objects to delete it. But then also we need to destroy it whenever it gets off of what the player can see. Now that we're in our target script, we're going to add in a new method. So in this case, we're going to override a method that Unity already has made for us, which is really handy. So if we private void, now we can type on mouse up, or we can type on mouse down. We'll also type in on mouse up just so you can see it. Now, because this actually happens so often in different games and in different projects, Unity has already made a method to detect whenever your mouse is inside of a collider of an object and you click down, or if you let go of your click, it will then fire off an event that will then immediately use whatever lines of code are inside of this block. So similarly, for when we did key presses, when you press the spacebar down or you let go of the spacebar, you could detect that and then you could fire off a line of code. In this case, we don't have to program any of that because we can just use these functions that already exist. So I'll get rid of on mouse up and I'll just use on mouse down for now. And so when the mouse is down inside one of our objects, we will then destroy that game object. Just to test our on mouse down, let's see if we play our game. You can see the boxes going up in the air. I clicked in the wrong place. 1's gone, 2, 3, 4, 5. And now you can see we can delete them when we click on them. However, they're still getting created and they're not being removed when they actually leave the player's view. Helpfully, in our project, we actually already have an empty game object created called a sensor, and it has a box collider already applied to it that has a trigger. So in our target script, we can actually use the on trigger.
This prototype is all about the user interface, or UI. And one of the most common elements of a game's UI is the score display. A game is just a lot more fun when you can tell what your score is. So by the end of this lesson, the score will be displayed on the screen, increasing as the game progresses. UI elements like this score display work a little differently than anything we've done up to this point. You can't just position it where you want in your scene, like you might do with a 3D model. The text has to magically stay on top of everything else, at the same position on the screen, regardless of the camera's position or even the size of the game view window. To achieve this, we'll use something in Unity called the canvas. The canvas is this gigantic rectangle that you can see in scene view, which represents the screen display. And we'll use the canvas to make our score display look great. So, to make all that happen, I'll see you in Unity.
We have the core mechanics of our game down, so when we press play, whenever we click on one of the objects, they disappear from the scene, and then if we let our objects fall off, they start getting removed from the scene because of our sensor. Now, to make this game even more interactive, we're actually going to create our first user interface to be able to actually get the score of our game. In order to do that, we're going to go to our project hierarchy. We're going to click on the Create button. We're going to go to the UI, and we're going to select
Text Mesh Pro.
Now, the first time you do this, it might ask you to import the Text Mesh Pro Essentials. So just make sure that you do that by clicking on the Import TMP Essentials button. Now, Text Mesh Pro has been added to our project. Now, Text Mesh Pro is a really cool feature in Unity to be able to add different user interface or UI elements, adding text to our games. So it makes it very helpful and easy to manage. One of the things you might notice you can kind of see, it's very difficult to see. In fact, Unity has, in our scene, added an entirely new element to our game. So you can see here, down in the lower left, that tiny little box is actually our game scene. And this massive rectangle here is actually where all of our different text and UI elements are going to be. In fact, if we actually drag this, and we'll make sure that we have our move tool selected, we can actually move this over to different parts of our screen. We'll just undo that for now. Now, all of our text and our UI elements are going to be rendered on this thing called a canvas. Now, this canvas is actually where all of our different elements are going to go. So if we add in buttons, or if we add in other text, it'll all be held on our canvas, which is the place where it manages all of our different UI elements. Now, with our Text Mesh Pro text underneath the canvas, we're actually going to rename this. So we'll rename it to Score Text. And you can see here that this has a pretty strange position on our scene, and we can move it around using our Move tool, or we can do other things with our canvas here to be able to place our text in certain locations to make it easier. In our